Hello everyone, good evening. Today I will explain to you all about backtracking, a powerful problem solving technique. So what is a backtracking? It is a systematic exploration. A backtracking is for the systematic approach to problem solving where we explore all possible solutions one step at a time. This technique involves building a solution incrementally, trying different options, and backtracking if a path leads to a dead end. And then we have tree-based search, where imagine a decision tree where each branch represents a choice. Backtracking systematically explores this tree, navigating through branches and backtracking when necessary. In backtracking fundamental, there are three things. Firstly is state space, then pruning, and last but not least is recursive approach. So state space is set of all possible solutions and it is called state space. It's represented by a decision tree. And then we have pruning, where a backtracking involves pruning branches that lead to invalid solutions. It reduces the search space and improves efficiency. And then last but not least, we have recursive approach. Backtracking is often implemented recursively. Each recursive call explores a different path in the decision tree. Next up, we have the backtracking algorithm, where there is 5 things. The firstly is initialization, where start with a partially constructor solution, and then we have exploration, where we can also explore candidate choices at each step, and then validation, where we check if the current choice leads to a valid solution, and then backtracking. If invalid, backtrack to the previous step and try another choice. Last but not least is success, where if a valid solution is found, return it. Next up is backtracking application, where it also in the puzzle solving, game playing, network routing, and graph algorithms. And then we have the advantage of backtracking. There are 4 points. Firstly is systematic approach, and then flexibility, then optimization potential and clear logic, and systematic approach where provides us there provides a structured and organized way to search for solutions. And then we have flexibility, can be adapted to solve a wide range of problems with varying constraints. And then optimization potential can be optimized by incorporating heuristics and pruning techniques. And then we have a clear logic, where the recursive nature of the backtracking makes the algorithm easy to understand and implement. Last but not least, we have implementing backtracking, where first define state space to determine all possible solutions, and then we have recursive function, where a recursive function that explores choice. And then we have validation and pruning. In there, we have implement checks for valid solutions and pruning logic. And last but not least is the best case, where we can define a best case for when a solution is found. Thank you.